would like to talk to you about this topic for an hour, but I have just 15 minutes, so let's start. So, before showing you a solution to solve this issue about how leverage confidential data to overcome the problem of data scarcity, let's provide a context. So, why people are scared about sharing a dataset with sensitive and confidential information? Well, because as all these scandals show, scandals that also have involved big companies, our privacy is not protected as we may think. I don't know how many of you already know about Netflix scandal, but okay, Netflix released this dataset about rating of its customers for a competition, a prize, and it turned out that it was possible to re-identify the identities behind these ratings by matching the information with the platform, online platform AMLD. And so, yet our digital identity is not protected, and breaches could occur, and people are worried about it. Because in this area of big data, we are constantly creating various amount of information and data of ourselves. Every time we download an app, create an account, every like, all of them contribute to shape this digital identity of ourselves. And it's not just about individuals, it's also about organization. And so the question, how can we leverage confidential data without compromising our privacy and the privacy of our organization? So let's see now some traditional techniques that have been introduced so far to satisfy and protect the privacy of individuals. And firstly, pseudonymity, very used in all the sector, and the simplest one. So I guess some of you already know it. It's very simple, as I said, because it consists by masking the personal identifiers. So here in this example, I'm going to take a few minutes just to introduce it, because it will be all along the presentation. And well, I was inspired by one of my last use cases. So it's about a survey released by a cantonal organization on Swiss company. So you have the name, some characteristic of the companies, and the answer to the question. So how does pseudonymization work here? Well, but just masking the name of the company. But its simplicity reflects also its weakness. Why? Because me, that I'm not an expert attacker, I was able in just a few minutes to re-identify and link back the seemingly anonymized data to the specific company with also surprising accuracy. And so how I was able to do it by matching information with the online public database. And this also is what happened with the scandals in the first slides. And so the point is that leveraging confidential data through pseudonymization does not guarantee a complete anonymization. And so let's see now another traditional technique that has been introduced to achieve higher level of protection, k-anonymity. And how does it work, k-anonymity? Well, the idea is to make each individual undistinguishable from at least k-1 other individuals in the dataset, here the organization. And let's see in practice, instead of having an exact number, we have a cursor, broader, larger value. Instead of, for example, a category, we have a general category, and so on. So at the first glance, k-anonymity seems to be sufficient because can achieve higher protection of the companies. but it comes at a cost. Why? Because here with this anonymized dataset, we sacrifice the utility of the data. We cannot do some analysis that we would like to do, for example, to understand if there is a correlation between the number of employees and a specific type of legal firm. So we limit the type of analysis we can do with this type of data. And so here the need of have another tool able to satisfy both the requirements, the interest of data utility and the privacy of the users. And here is where differential privacy comes in. But firstly, what is differential privacy? Well, differential privacy is a mathematical framework that preserves the privacy of individuals while still allowing scientists to extract meaningful analysis from the data. And the intuition is to add, in a smart way, a calibrated random noise that can create an uncertainty about the identities behind the numbers. And the interpretation now, in the world of differential privacy, is to combine generative machine learning with this theory in order to create a synthetic private data. And that can be used by scientists to extract analysis and at the same time, with mathematical guarantees, protect the privacy of individuals. I'm going to details later. Let's see now just in practice the application here. So as you can see, the data set, the rows are, there are similar rows, but with slightly alteration, okay? But the idea is to preserve the privacy while still having the same distribution in these synthetic private data, because these synthetic private points closely resemble to the original ones, in the sense that the distribution are still similar. The general behavior here, we have the original data set in red and the blue in is the private one. Okay, the distribution has slightly changed, but the behavior is similar. And so here the advantages of differential privacy that you can create the same data set, but with probably you can protect the privacy of individuals. Let's see now some a general overview of the methodologies, because this theory, mathematical theory, at the beginning has been implemented to add the noise directly to the output of queries to database. But it was turned out that it was necessary to limit the number of queries. Why? Because a smart attacker can repeat the same query many times, collects the results, averages them out, and remove the noise and get the exact answer to the query. And so I will say that the world of differential privacy shifted toward combine artificial intelligence with differential privacy. So the idea I introduced so far, the approach to combine generative machine learning model, and with this approach, it's possible to create a synthetic private data that you can interrogate, query an unlimited number of times. Major players of big tech industry have already implemented this mathematical tool in their system data analysis processes. And some of these libraries are also open source, and you can find also lots of documentation online. So feel free also to ask me in later at the booth. And it's crucial to understand that it's possible to integrate these these methodologies that have been studied, but it's finding the right way to setting the parameter, the amount of noise, and choosing the right method is not straightforward, is challenging, and often requires the expertise of a differential privacy specialist. So this is why at Artificially we decided to implement our own solution that in order to address also this problem for the business. And our solution now, patent pending, is ready to use on data set, structured data of whatever context. It's simple. It takes data set in input and it generates synthetic private data as output. And it could be applied on whatever context for structured data. Let's now do a recap in order to answer to the main question: how can we leverage confidential data without compromising our privacy and the privacy of our organization? So we have discussed pseudonymity. Well, with this tool, you can do whatever analysis you would like to do with your data, but you don't guarantee the privacy of the user. So, but on the contrary, with the k-anonymity, you can protect, you can achieve a higher protection level, but you sacrifice the utility of data. So differential privacy comes a solution that can satisfy both the requirements. And so yes, absolutely, with the differential privacy, we can leverage confidential data. And in addition, this tool represents also a solution that can change the way we intend to handle now leveraging dataset with sensitive information, and so represents a powerful tool to achieve data anonymization and can change the data privacy world, because it could be applied on financial sector and also medical sector, so whatever context sensitive data are there. Well, I guess my time is up, and thanks. Before I would like also to extend a warm thank you to my team and colleagues. So.